Woo lads, welcome to Sesh 6, massive truck outside, John Lewis delivery. I thought Royal Mail had just started using like humongous articulated lorries or something to do the delivery work, but it is just John Lewis actually, because the postman was talking to the truck driver. What a waste, driving such a massive thing into such a small neighborhood. Alright, check it out. Session 6 is going to be the last one. I am, yeah, definitely burnt out. From the project being more difficult than expected, so it's not, I wouldn't call it too difficult objectively, really. It's not that hard, certainly compared to some of the bash your head against the wall maths problems and that kind of stuff from uni. So this is, I've been making consistent progress every day, but definitely a lot more work needed than I thought, and so just having the deadline looming causes, it sort of leads to burnout. So this will be the last sesh. I'm going to try my best, I'm going to try my best to get through question 2A, finish the debug, do what I said I would, do at the beginning, and get that out, get question 2A done. And yeah, that's it really. Then I will just take a break. Unfortunately, I think the break is going to last until July because I've hit the busy period effectively. And I'm going to finish streaming El Rafto, this difficult Raft project. So questions 2A, B, and C, implementing the data phase, the persistence, all this stuff that hasn't been done yet. But definitely needs a break, so I can collect my thoughts. And I definitely am not. Last sesh definitely I was feeling like I had stopped enjoying it really for the first time. The whole sort of streaming, doing Komsky stuff. So I'm hyped for today to get the debugging on, do that. But generally speaking, it's like there's the definite reluctance. It's no wonder I got to bed so late, woke up about 45 minutes ago. Spent last night reading about like Zelda lore, because I just couldn't bring myself to go to sleep because I knew I'd have to do this in the morning. So yeah, if you're not doing it for the LOV to the E, then yeah, you got to reconsider. But I'm not, it's just a temporary thing, and I'll just come back straight at it when I feel a bit rested and when I have a slightly healthier appreciation of how long this task is taking. Like, it's taken so much longer than MapReduce. It's actually unreal. I'm sort of converging on 17.5 hours, the same amount of time spent on MapReduce. With my Raft VOD playlist, you can see that. The collection, which I've linked to in my Twitch page on desktop. But yeah, I've done so much less. I haven't even finished the first question. I think I've passed the first test, but not the second one. And the first two tests are testing the first question, the first part, question 2A. And then there's like 7 for the next part and 5 for the last part, I think. So lots of tests that are going to need to be passed. I mean, it's really cool shit, all of it. Like, I'm really enjoying putting together these concurrent programs with lots of different pieces. But it's just a bit of an ordeal, getting your head around it, getting it all to work. And if you assign less time, then that's, the number one way to get burnt out, assigning not enough time. Because I had no idea in advance how long it was going to take, so I thought, 7 days is reasonable. Well, this is day 6, and it's not even close, unfortunately. And also, the fact that I was doing 4.5 hour streams, like the learning phase and then the coding phase, and they all took like 3.5 to 4.5 hours, I think. yeah, definitely would, you know, just break it down a bit more next time. But I was so keen to just like get out the question 2A question, you know, I wanted it to sort of conform. I guess the splitting hasn't been helpful in that sense. It's been a bit unhealthy, encouraging me to try to push an entire section into one stream, even though it's just been so reluctant to fit into one stream. And so, like, with the debug that you've just seen, I've definitely had to split that over multiple sessions because it's just too hard, far too hard to do that in one session. But like I said, you know, this pales in comparison to pure maths and even just music learning by ear transcription. Those two things, like, you bash your head against the wall for hours and are not guaranteed to learn anything, whereas Komsky is always in a straight line. You're always making progress. It's just if it's slower than you wanted it to be, that can be frustrating. But yeah, you know, as soon as I noticed I was kind of losing the drive, I decided, yeah, I'm gonna take a break, hiatus. So it's gonna be on a break. I'll resume probably in July because I'm not gonna have time until then, unfortunately, like any time at all. And then I'll look into projects 3 and 4, whether or not I'll stream them, I'm not sure. Happy to finish streaming 2, just, you know, as to keep the experiment going. I just saw somebody I know from Pokemon Go walk by with 2 phones under my arch. Local player, cool. I'll give her a shout out. 1307, okay. I'll remember that. Yeah, but yeah, the downside of streaming is that you know, you have to sort of fix your routine, which is good in that you'll definitely get it done, but bad in the case that you wanted to just sit down and work on something in your own time, just crack out. Like, for example, that little thing that I said I wanted to implement at the end of last stream. That thing, which I'll describe when I begin the stream properly. That thing, I just, you know, I would have pushed ahead at some point yesterday, just tried to do it, come back at it later, just, you know, taking a chill. But this way everything's on stream, and that makes it a bit more, a bit less governable by manual motivation, just put it that way, you know what I mean. So, yeah, that's all I have to say about that. Last sesh, but not really because I haven't finished. I'm not anywhere close to finishing, but last sesh before the hiatus, I'm going to try to finish question 2A. And it's like I said at the end of the sesh 5, the previous sesh. The last sesh is in the previous one rather than the final one. Both of those, what the word last means them. I'm going to try to so, you know, look at Raft, the projects. What I'm going to try to do is I'm going to try to split this up so that every phase change, like this one, again I have to do the maximization thing because Chromium doesn't work. Every phase change like this, I'm going to do at the end of a function rather than, as you can see here, at the beginning of one. So each function is run as a concurrent go routine. So you can see, for example, func candidate, and then it says go, run the candidate, which means it starts this piece of code concurrently, and that can keep it waiting. Whereas I want phase changes to be triggered ASAP. Because, I don't know, I just think it'll help the code run more efficiently. Phase changes are very quick, just lock and unlock, do the edits. But also, yeah, it also means that because the phase change happened in the context of the function that called the next routine, I can print a reason why the phase change occurred. So here it says timeout. I can just print that as, you know, this became a candidate because there was a timeout, and I can print that in one line. So let's wait for this cunt to piss off and then I'll begin. Yeah, I have nothing else to to amble about, preamble anything. I'm just going to start by doing what I said I would do. The size of this lorry, pretty massive. It's like one of those M1, A1 lorries, just casually chilling in my neighborhood that has like no space in it. It's going to take it a while to get out because it's just so massive. So yeah, yesterday, at the end of the sesh, I split everything up into 4 files because I realized, well, yeah, I figured out how to do that by, just appending package Raft at the top. That specifies that all of these belong to the Raft package. And so I could divide it up, so I could have like the append entries. This is called append entries, mate. Yeah. So, the append entries RPC, the arguments sent by the sender, the arguments sent by the receiver, the receipt handler, and the send handler. That format of having those 4 functions, right? Oh, sorry, 2 structs and 2 functions, that's what I mean. Which I copied, unmodified from, I'll save that, just a typo. I copied that unmodified from the request vote handler. So I have, the 2 RPCs in separate files. This which contains, the stuff about, the make, kill, start interface stuff, plus some stuff about persistence I haven't touched yet, and the original state variables, and some variables about timeouts as well. So you'll notice no matter which file I define these in, they're accessible in all the files labeled by this package Raft statement at the top, and that's very, very useful. Much better than I think any other system for importing and exporting that I've seen. That you can actually split things up into files, but all the files share variables. It's like you have literally just divided one file into many files just to make it easier to navigate and nothing else. So that's what I've done. I do have to do import statements for every file individually, which is a bit strange considering I can share variables, but it's not a big deal. And Raft flow is the file that contains basically everything that I'd done. So the code that starts when it becomes a leader, the heartbeat code, when it becomes a follower, the await election code, and when it becomes a candidate, which I haven't split up yet, but this could be a do election section as well. Do election section. So yeah, with that in mind, let's begin. I'm going to implement the change that I said I would, which is do a phase change at the end of a function. And after that, I'm just going to have to sit down and debug the log to find out why it's failing the test, okay? Yeah, I had a problem running multiple tests in the same session with print statements overrunning because the app could not be exited correctly for some reason between tests. But that's something I'm going to totally ignore for now, just by running tests individually for the time being. I'll see if I can sort that out later, but yeah, just do individual tests for now. I'm happy to just do that, and we'll be on our way, okay? I have until 3 PM to get all of this done. Bit of pressure, but honestly, going beyond 3 PM, even if it's not done, I am leaving it alone and going on my break, so it will just be neat for it to be done by then, because I've already spent quite a lot of time doing the debugging. The thing below says I am debugging today, so let's do it. Nose is still a bit blocked up, because I'm streaming within less than an hour of waking up, so I'm very much pushing ahead. Okay, so all this code. The RPC code is kind of nice because it's just executed each time there's an RPC. So I would say, there's no problem thinking about if the code's concurrent when which function is running when. That stuff is not important for RPC, but it is important to get right in the rest of the code, which is all this stuff. So yeah, let's do the phase transitions in the correct place. So, I mean, it's one of those things that's probably easier said than done, but I'll try my best to implement it regardless. Every time a phase transition is called. So, for example, heartbeat. Oh yeah, do you know what calls a phase transition? Request votes. You know, you can see these lines of init follower here. This is request votes, yeah. If RPC term sync happens, then yeah, I'm gonna assign follower here. This is lock and then defer on lock, which means that this piece of code is very much within the lock, so I can just do a phase transition here. Rf.phase equals, my suggestion thing is just not working very well. Rf.phase is going to be set to follower. Okay, and we're also going to give a reason for assigning to follower, which is to say rf.me, you know, me being the peer number. That is, so these print statements about phase changes, you know, rf.me identifies which peer, 0, 1, or 2 in the test. They're going to be 3 peers running at the same time, 3 servers. So we're looking into basically, you know, who am I, and I have just become follower. Alright, and I'm also going to put down a reason for why I've become follower, which is RPC term sync fail, right? As in, I had an out of date term, so I forced myself to become a follower. Don't forget, you know, the rest of request votes still happens in either case, because all that the rest of request vote does is it writes down a reply, okay? That's all that it does. So I'm perfectly happy for it to continue just doing that, even though this has now become a follower because of term sync. So I'm going to say, yeah, I'm going to call this term sync fail. That's going to be the log for why the transition has happened. And I'm going to put request vote just to make it clearer what it is instead of RPC, the generic term. This is also going to happen in append entries. Append entries does the same thing. You know, and this function is definitely going to deliver an election reset message regardless. Election reset messages are good because they keep things followers, and that's something we're trying to preserve in general stability by doing that. And so the excuse me. Yeah, so it's good to send out an election reset even if this thing is also going to become a follower. Well, append entries handler is a follower anyway, it's just that it could be a candidate as well. But it's reasonable for it to reset its election in that situation anyway. It could be a bit dodgy, but I think it's okay. So yeah, I'm going to run the follower code here, and then payloads, it sets itself to be follower regardless at the end. Yeah, the code here is a bit sketchy because it has to become a follower but for 2 reasons, and here it's just doing some replies, so that's quite trivial and not going to cause a problem. But it has to become a follower. If this happens, it's become a follower both for this reason and for the it received the heartbeat reason, which also converts things to followers, right? So just have to be careful. Whatever runs the append entries handler, i.e. whatever receives an append entries message, is automatically going to become a follower, okay? And the reason for that is received heartbeat. Yeah? That should turn things into followers, I think. I'm not 100% sure, but that's how it's supposed to go, because I didn't find the that particular piece of information in the documentation, but to me it makes sense that if anything receives a heartbeat, again, I'm trying to keep things follower, so make it a follower in that case. I should definitely register term sync fail here, although it doesn't yet become a follower if there is a term sync fail, because it's going to become a follower basically immediately afterwards. So this term sync fail thing, I'm going to put in brackets to replace the word follower. Let's just call it follow, because the point of having this in brackets is this is not actually turning into a follower at this point. Although you see I have actually assigned it to follower anyway. But regardless, I'm not going to do that, because it's going to be assigned to follower down here anyway. Okay, there's no problem doing that. And yeah, do you know what? I'm going to defer an unlock as well, because I just want to get some practice using that idiom for writing the code, which is to say when this function finishes, so when we get to the bottom, because it doesn't return anywhere else. Well, actually, yeah, anywhere the function returns, it just does an unlock at the end. That's what this line of code means. So this is, defer run stuff after a function returns. So this function will run the defer statement just after it's done, which is a fun, curious Go exclusive feature. Okay, so yeah, that's it. We've assigned the phase transition here as well. Should really put that in the correct order. So phase transitions are always going to be matched by corresponding print statements. Send append entries is also allowed to turn things into a follower. At the point where the RPC comes back, here it is, we do a lock and unlock in order to handle the response, and handling the response is just going to involve doing the same thing, assigning myself to become a follower and running the follower initialization code. Followed by a fresh print statement. Print statements, immediately precede starting the relevant Go routine. So because this code is running sequentially in one Go routine, and it never pauses, Go routines don't pause unless they become idle, I'm pretty sure. Which means that because this is just a print statement, this should immediately follow it whenever it appears. So it'll make it easier to debug. We know init followers always run after a follower statement because of synchronicity, basically. So yeah, term sync fail, append entry sender. Okay. This is request vote receiver. That's failing to do a term sync, and here append entries. Well, no, as in it's successfully doing a term sync, but its term was out of date, and so I'm specifying whose term is out of date. The append entries receiver, if it's in this case it's append entry sender. Again, these functions always just immediately exit, so we're not going to have problems with them. Double doggo outside with a dashing blue coat on a woman. Double doggo. Yep, request vote sender. It's going to be the same situation. P rf.me with the statements follower, reason being term sync fail request vote sender. Right, and yeah, I just noticed in append entries, yeah, it says receiver here, it says sender there, request vote, receiver, and sender. So that's all fully organized. So these are, just 4 different ways that something can be triggered to be a follower, and those are all term sync fail, except in the case of receiving append entries, in which case, yeah, this will trigger it to be follower, but it was going to become a follower anyway because it received a heartbeat, which is the append entries. Anytime it receives append entries, it automatically becomes a follower. That's totally legit. So yeah, now we have to go back into the Raft flow and to make sure that all of that code is kind of abiding by that kind of way of thinking. So once a heartbeat is triggered, for example, let's look at heartbeat first. It sends out bare RPCs and does not even really expect a reply from them, which is totally cool and all. But then it sleeps. Then we do a phase get, and if I am still leader, quite happy to run heartbeat again and not affect my state. No override. It's just, I am still at this point, because this is again synchronous code. At this point, I am leader, so I am just going to hit a heartbeat in a. Oh, do you know what the problem with this is? Well, there isn't really a problem. It hits a heartbeat timeout, and at that point there is always going to be a context switch. So I was just thinking maybe I shouldn't be running it in the same context. Should we do a phase get up here as well? No, we shouldn't. The phase get should be done after the sleep is finished. Or just don't, and instead do it at the top of the heartbeat. Yeah, just do it here. Hello, hello. Hi. Hi. What's up? Always nice to receive a message in the chat. Let's do it here. Yeah, so I just said, when it comes to putting together this heartbeat, what I'm going to do is just put in a line of code that returns if I am no longer leader, and I'll put that at the beginning so that I don't have to lock and unlock twice per heartbeat. So that should be all good. I'm alright. Just earlier I was saying how I was getting a bit burnt out by this project because I was, I guess, trying to jam it in too little time. So I think this will be my last stream until possibly July. And so I'm trying to hype myself up, and in the next hour and a half just crack out the debugging, finish the debugging, and pass the tests for part 2A of the project, MIT's Distributed Systems course. Project 2, Lab 2, Raft, 6.824. Part 2A, that's what I'm trying to finish. Raft is, complicated as fuck, so this is only a small part of it, what I'm doing here. Leader election and heartbeats. But generally speaking, yeah, I have these 2 tests to pass, and so I'm going to try to do that. That's what I'm working on right now. Looking at my heartbeat code. Yep, so let's just go ahead and do that then. rf.phase. Yeah. If my phase at this stage is not leader. Yay, another council van outside just causing random pollution. So leader test just happens here, and if it's not leader, it just returns. It didn't even run the function. So I think, yeah, doing these tests at the beginning is kind of nice. Yeah, shit, I have to be careful here. Have to be careful to unlock whenever there's an exit point to any of these functions. We have to drop the lock, or else the code will just hang up. But the point is, the lock is necessary here because phase has to be tested. And accessing anything from RF that can be edited requires a lock, even if it's just an atomic read of the thing, because, I don't know, MIT said so, you know. I see. Yep, seeing is good. Make sure that you keep seeing the rest of your life. So all I have done is replaced this piece of code here. And because heartbeat now doesn't immediately trigger a heartbeat, first it tests if the phase is leader. That means I can just do tail recursion properly, where I just literally just run the heartbeat code at the end. So I'm, you know, calling the function within itself at the end so that the heartbeats keep on coming and they don't stop coming and they don't stop coming. Well, they do. If the thing stops being a leader, it will check if it's a leader at the beginning, and if it's been assigned to follower for any reason or candidate, it unlocks and this code loop is just broken out of. Okay, so heartbeat, I'm pretty happy, is working correctly then. The leader codes, what is this doing? It's from the way that I wrote it last time. Running heartbeats. I mean, I probably should just write go here anyway, as in run the go routine for a heartbeat in every situation. Just to have that atomicity, like every time I've done a new kind of routine, I'm calling it with go to make it concurrent. Even though here it's not necessary, we can just keep on heartbeating. Yeah, here it's really not necessary because all the heartbeats are tail recursive. They literally keep coming one after the other. There's no real point starting a go routine. I'm not going to do that, even if it would be kind of sensible, I guess, as a way of... I don't know, it's just, I think it might just be an aesthetic thing. I hope it doesn't cause any problems. Not actually a functional problem with the code. Alright, yeah, let's have a look at init leader. What does it do? It checks if the thing is candidate, because only candidates are supposed to become leader ever. So if it got assigned to follower, this is like in the meantime. So this is, you know, the code for a candidate. What a candidate does is somewhere at the bottom, and what a candidate's going to be doing is turning this thing into a leader, turning itself into a leader if it has, you know, given an event has happened. That event is going to be, it was voted for. It collects votes and becomes a leader. It doesn't matter what the event is. The point is, you know, that triggers, that's the only way something can become a leader. The server, the peer, can become a leader. And so it immediately enters this code, but because that is run concurrently, we have to check again if it's a candidate. In case it was turned into a follower, in the meantime, it should probably just immediately abort. Well, you know, it's not actually a big deal, because everything that the leader does is going to depend on the heartbeats, and at each instance we are already checking if it is still a leader. So I guess we don't even necessarily need to actually do that, now that I think about it. Yeah, I think so. I think we can do without another test of is it leader here, because even though the leader code can just, even though if it turns into a follower, the code that initializes the leader can run, it doesn't immediately do anything, because before it does anything later on, it's going to do a leader check anyway. So yeah, I'm happy to just delete all of that. To be honest, yeah, so we're not checking candidate, we're not assigning to leader. We don't need this because this is all going to be moved into the, don't forget, I'm restructuring so that all of the phase changes are done at the ends of the relevant functions, so we have some more context of why they happened. I can put in in the p function, which is a print function, a debug function. So I can do that, which is why I don't need to do that here. And you know, literally all that this code needs to do, there's no longer a need for a lock because I'm not going to do this test either. All it needs to do is run a single heartbeat. So the code is totally trivial here. And we don't need to go routine it either because why? It's just one line of code. No need to start a separate concurrent routine. But, I mean, the point is, here I've written down do heartbeats, so you're like, oh, why don't I just ditch this function entirely? Well, later on in the project, leader is not just heartbeating with empty append entries, it's going to be heartbeating with something else as well. It's going to be sending data. I'm not sure yet if I'm going to have a separate function for that or if I'm going to put that in the heartbeat function. But for the time being, this is a kind of separation of concepts. This is what the leader does, and this is just the initialization code. So they serve different purposes, even though the initialization is pretty trivial, if you see what I mean. So that's cool. So in the leader code, I'm just going to... before I forget, I'm just going to drop this in. Change phase to leader, and then say like rf me, I am now leader. And the reason I'm leader is because I was elected. That's the only reason anything can ever become a leader, so I'm just going to drop that in. No worries, come back as you please. Well, if he's BRBing and I'm just saying that on stream, then if A's BRBing, then A's not going to notice I said that anyway, but no worries, stick around. Should be going until 3 PM. So yeah, RF phase is leader. I'm saying I have become leader because I'm elected. I run init leader in a separate coroutine. Maybe this should not even be run in a coroutine because it's a linear line of code. But at the same time, I probably should because all of the code is going to be parallelized. And there's no reason to prefer that this happens immediately, or do we want the leader code to happen immediately? Maybe we can affect the priority order of execution of this program just by deleting the word go here. So again, the difference, go triggers things into functions to be run in separate routines, go routines, coroutines, so they're concurrent. But if I delete this, then this immediately continues into the leader code, which is cool. I could do that if I wanted to. Because then there is no context switch. I'm pretty sure it's not allowed to context switch because it doesn't have a pause. So it would immediately continue and immediately go into the leader initialization and therefore the heartbeat. Which is good because sending that out is going to turn everything else into a follower. If something's been elected a leader, we want to give it a chance to demonstrate that it is the leader before it gets reset. So I think honestly it would actually be a good idea to run init leader here, okay? So we just have to be very careful now because this is no longer a go routine. We have to be careful that to make a note that the function it hasn't returned, but it has moved on, and so we have to make sure that we actually do a lock unlock here. And likewise, unlock is also going to have to happen here. Okay. That is a highly interesting accent outside. Okay, what is the else case in this piece of code? Become candidate again. So, that is not a phase transition because this is already a candidate and all of this code is under the lock guaranteed to still be a candidate at this point. But what I am going to do is just do a print statement saying I am now candid that. Let's put it as candid. And why am I now candidate? Because lost vote. You know, if something loses a vote, it immediately calls another vote because it's fair enough. I guess it's a decent enough system. Yep. So no need to reassign phase because it's already a candidate here. You know, and this assertion holds true because it's all protected by the lock. Should we just write down here how many votes there are? I guess there's no reason why not. Yeah. So, you know, I'm just putting, as much useful extra contextual information for debugging as possible. Don't forget P. P is literally just an alias to Go's print line routine. But I have it as P so that I can edit it later to turn it off. And I can Control F through the code to delete all the statements at the end, but I'm definitely going to want to keep all those statements in for the time being. Just to get the system up and working. So here, vote count and decision phase of the code. So again, I'm just looking at the main candidate election code. This is all still in its candidate, but all the candidate does is a loop of election, so I'm happy to just leave the code there anyway. Don't forget this is no longer necessary because we assign phases at the ends of functions, so I'm going to delete this and it's going to come back somewhere else, I wouldn't worry. Current term, yeah, vote count, then it concurrently requests all of, it does all of this voting concurrently requests. This does not need to be under a lock at all, does it? There's nothing here that is lock sensitive. Because we only need to lock the variables in the properties of RF that can change. And none of these properties can change. rf.me is always stable. rf.peers, the peers list also never changes. So there is no need to, rf current term is necessary here. Okay, that is something that is necessary for the lock, unfortunately. Well, just to make the code a little bit simpler, what I'm going to do is make a term variable here. Term is going to be, term needs to be assigned after. Okay. Term is going to be initialized here to an empty int variable. Then we lock, we assign current, whatever the value of current term is, to the term variable. Then we unlock. Because, nothing else. This should be here. Because we can, nothing else requires the lock at all, so I can just, term is term. Send out all the votes, no need to relock or anything. Also, the thing I would say about init candidate is we may as well also have a return statement, the same way we had for heartbeat, if the phase is no longer leader. If the phase is no longer candidate, just return, Happy to just include that because that's a logical place to include it, even if it's possibly never going to be used. So we do modify our state, our current term, but let's not do that. Phone's not on silent again. Let's not do that in the case that the phase is actually not candidate. So straight up with the unlock. Getting notifications, but they're not from the chat. I mean, they're from this stupid phone. The phone that I'm using, yeah, it's the webcam is actually what's making the notification noise, because the webcam is actually a Moto G3 phone being run with some really sketchy software called the Droid Cam, which is sort of bringing in making it work as a webcam. That's what I was trying to say the whole time. Just clumsy ass way of speaking on my part. Okay. Yep. You know, all of this. I mean, all of this is literally just I send out votes. It really does not matter if votes get sent and then don't get received later on. Well, there's a votes channel that is designed to collect votes from send request vote, and that gets sent off. You know, each channel is told, it's given a reference to where it should be voting. You know, so send request vote, again, that goes from the candidate to every other peer, every other server running this code independently. And it asks for a vote, and then that thing replies with a vote, and all the votes end up in the votes channel. But I mean, if this routine gets quit for this reason, then the votes channel is going to get deleted anyway and cleared up, and all the RPC, you know, once it gets dereferenced, it will get garbage collected, and it's referenced by all the RPCs. So once all the RPCs come back, and this code exits, that will get garbage collected, like as in deleted from the memory, because it's not necessary to leave it lying around. You know, if you don't garbage collect all your variables, you will just keep stacking up RAM and run out of memory. Eventually, that's called a memory leak. When your program keeps functioning in like a cycle, but takes up more and more RAM. Really, that's all I have to say about this. Send request vote, then the votes come back into the votes channel. This is all working fine. This piece of code here is so again, my paradigm is that the function that calls, you know, for a phase change is the one that does the phase change itself. So here I'm gonna put in the phase change. This is me restructuring my codes pretty much. We're gonna run rf init follower. Because I am now a follower. And yeah, I'm also happy to run that synchronously in the same line. Well, no, actually, that should be a go routine, because something becoming a follower is not a pressing emergency. So I'm happy to run it concurrently, let it get picked up by the scheduler, rather than immediately afterwards, which is what I did for leader, because if something becomes leader, I should try to make it as easy as possible for it to send its first heartbeat, so that it stays leader and doesn't get challenged. Because, you know, election reset is the piece of code that is the channel that the heartbeat RPC handler sends to in order to keep things as followers, right? So I'm trying to get things to stay as followers as much as I can, and get the leader to stay a leader. So that's how I'm choosing what to run immediately and what to run deferred. So something becoming a follower, that's fine, that can wait. But something becoming a leader is a pressing emergency. You know, the way the code is working now, I think becomes leader sends first heartbeat, all of that happens immediately without a switch to a different concurrent routine. And so in that event, election reset is going to get populated for all of these other things immediately, and so everything will be told it needs to be a follower without triggering further elections. Okay, and the code returns here before it does another vote count or whatever. So if that happens, so I think that's the right way to do it. Okay, let's put in a print statement here. Just using capital P for print statements. I have an alias to println from the goes fmt in write to console library. Yep, so I get assigned to follower, reason being timeout. Is that timeout? No, this is actually not timeout as such. This is I used to be candidate, but now I'm follower because well, it is also a timeout. It is. Oh, it's not really a timeout though. It's an interrupt. It's getting interrupted by a heartbeat. Does this code actually work properly? Because receiving a heartbeat automatically does an interrupt, right? And the heartbeat handler sends something to election reset. So I'm assigning a phase of follower in two different places twice. Once here and once. Okay, so let's take a look at append entries is what we're using to transfer heartbeats. Okay, that's what append entries does. So what this is doing is it's both telling it to become a follower because it received an append entries, and it's also sending a message to election reset, and it will always do both. So here, receiving from election reset is telling it again it needs to be a follower, which is okay. It's redundant, but I think I'm happy to leave it in. Even though something can become follower twice that way, it doesn't matter. That's all well and good. Just make sure that well, maybe I should look into splitting it up so that I don't actually have that problem. So that only one piece of code ever sets something to be follower. So instead, why do I not? Well, listen, election reset. If the only thing that sends into election reset is going to be this handler code, which is also guaranteed to synchronously have assigned this thing to be a follower. So it is definitely a follower after that, unless there's I don't know, some sort of race condition that's assigned it to something else. Yeah, you have no guarantee that that's not happened. Oh wait, no, we do, because we have a lock on the entire handler. Oh, sick, okay. No, that's good, because what that means is it sends an election reset and gets set to being a follower in the same sort of logical block of time, as in it's not possible for that process to be interrupted because it's all under a lock, right? So it will definitely be set to being a follower during that section of code. So maybe it's not important for us to do that again, because this message will be received, and then whenever this is picked up, it's a follower again, unless something changed. But if it did change, let's deal with it some other way. Yeah, do you know what? I'm happy with that. Init follower will definitely also be run in a concurrent routine there, so I don't need to run it again. And check it out. Phase sets and run the routine, neither of those are actually going to be necessary. So instead, let's just straight out return out of the function as soon as election reset gets hit. And that's literally all that this code is going to do, okay? If it manages to get to the end of this, because it managed to pick up literally all the votes, There's a problem here that there's no timeout, so if this has to await literally all of the votes. Okay, all of the votes have to come through in order for this code to continue. There isn't any kind of timeout that says continue. We can put in a timeout immediately if we want to. That's not actually difficult. I would know how to do that. That just says continue out of this code in the events that we have not received a vote. Interesting, interesting. Yeah, because I've just noticed that it is possible for a vote to literally hang here if it cannot collect all the votes. Maybe we need more print statements in the candidate code anyway, to be honest, because it's not that easy. Code is a bit difficult here. So yeah, let's do that. Yeah, let's just put in some print statements. Requested votes. And here, print statement saying received votes. And then vote count and decision doesn't wait on anything, so there's no need to. And we already have these other print statements anyway. So you've got to watch out here. We have our select block. That is going to time out, unfortunately. As in, it's gonna get blocked completely if in the event that nothing replies with a vote. Surely it is possible for us to handle that somehow. You know, send this is done by an RPC. We sent the requested votes out, right? So we just need to make sure that we are, in the event that the RPC times out, we are sending a vote of false. False? Yeah, it has to be false because this is only allowed to be elected by a majority of active peers. Sorry, a majority of all the peers. And the reason for that is that it guarantees that if something is elected, that's because at least half of all the peers voted for it, whether or not the peers are still working. And the reason we want that is because we only want the code to continue in the first place if at least half of the peers are working. So that's the reason for having that. Don't forget, Raft in general, if half of the peers broke down, over half of them broke down, it literally just pauses and waits for them to come back. So, and it does that by continually calling elections while it waits. Eventually it will get a majority, and that's a majority of every server voting for it. Okay, so that's it. We just need to make sure then that send request vote actually results in a false if the thing is not replying. Okay, we can do that quite easily. So the voting channel, by the way, gets sent by reference as a done channel into request votes. So, you know, this is where it's picked up. So done channel is the voting channel that has been, I've given it a different name. No particular reason. I guess I could call it votes here, but I called it done because of, you know, in the sort of way of thinking about Go, it's all about replying with results. I think this actually already does what I am trying to get it to do. The call here definitely times out correctly, and because vote granted is initialized to false, it definitely goes into the done channel, right? So false votes are actually, okay, so what I was worried about not happening does actually happen. So again, if this times out, what happens is the call function returns false. It doesn't even matter, but the point is the stuff in reply, the reply struct, right? Term and vote granted, these are initialized in Go to 0 and false because those are the default values of these primitive types, integer and boolean, which means that that's not edited, so it remains false when this comes back and fails. And so here it's taking that thing, the false, and sending it into the voting channel. So this works. Yeah, this is guaranteed to not lock up because this times out correctly, or at least that's how it's designed. And MIT says that that is what happens. I can assume that, so I'm down with that, So yeah, no problems actually. What I said is what I said I was hoping would work here. Does work, so it is going to receive all of its votes through this channel. If there is an election reset, just return. That means that it has to have become a follower during one of its RPCs. So I am going to, print statement here. Vote interrupted. And then it just returns. No need to become a follower again, because that's already happening, I hope. I do hope. Yep. All good. Is that all of the... Yeah, we need to look at the follower code finally. Init follower and await election. Okay. So init follower, for starters, something became a follower. What does it do? It runs wait election. Yeah, saying we should never reinitialize a follower. That's true, because else we could have multiple loops of election timeouts and it'd be total chaos if that happened. I mean, but the thing is, the way I'm doing it now, if it's become a follower, it has to... it calls the code immediately. So what we need to do is be careful. We can't do it this easily anymore. Instead, every time something becomes a follower, we have to make sure we don't call init follower unless it is actually... It has to explicitly become a follower. It has to have been something that is not a follower before it gets phase changed to follower and init follower is called. So again, the init function should only be called if something has changed. In general, generally speaking, the init candidate, init follower, init leader, all these are about the thing becoming, starting to be a particular phase for the first time. And so whenever these are called, yeah, let me, because it's not, I mean, my code isn't behaving that way. There are a few kind of basic assertions that I want to deal with. Let me just make a note of them in Notepad, okay? So, init phase, whatever the phase is, like follower, leader, candidate, how should I write that? Init phase should only be run if there is a phase change. Okay. Right, and the rest of the code, like for example the heartbeat, that does not require a phase change, it just requires something to remain in that phase. So what I'm going to do is apply that way of thinking to init candidate, i.e. split out all of this code into a separate function. Well, let's just immediately do that by renaming init candidate to You know, we have here a wait election. I'm going to have a call election function. Okay, so carefully here, I'm also going to write a new init candidate function. And the point of that function is there is no looping. It literally just runs call election immediately. So it's going to be, again, trivial code that can probably be replaced later on. If we try to refactor, I can get rid of it. But the point of having call election separate is that call election is code that is looped by you know, this thing while it's still a candidate, and it tests for candidacy at the beginning and returns if it's no longer a candidate. But init candidate should only ever be run once. This is important only really for init follower, which definitely should only be run once. The others should also only be run once. It's important for all of them to only be run once, to be honest. All phase changes should fail if no actual change, okay? This is what I'm going to do. I'm going to put in a new function. Function, again, it's going to be a method for Raft. It's func keyword, isn't it? phaseChange, okay? What this does is it takes an argument known as the to phase, the phase that we want it to change to. Okay? That is going to be a string type. And it has to return it returns a true or false. Okay, no brackets. It returns true or false depending on whether the change succeeded or not. So I'll show you guys why I'm thinking in this way, phase change and that. So this is what this function does, and it'll become clearer, you know, why I'm doing this once I've typed out the function. I'll be able to explain it. First, we do a lock. And while we have the lock, we define a new variable called from phase, which is going to be what the current phase is. All right, if statements. If from phase is not equal to phase, then we run a phase change. Okay, what that is going to mean is that we for starters assign RF phase to phase. We also let me think about this. Okay, the print statement I'll worry about at the end. We're going to return rf.mu.unlock. We're going to return true, but also after the unlock, what we can do is call the initialization routine. Okay, so the way we're going to do that is just by writing down a quick dictionary. Phase var phase let's call it in its phase, and it's going to be a dictionary. Actually, can I write that as a bunch of literals? As if this were JavaScript or whatever. Leader, follower, candidates. Yeah, I guess this doesn't have to be a global variable. It can, but no, I'd like it to be global, so it's just always in memory. Okay. Yeah, so just a few of these. What just happened? Please, Windows. That pixel perfect scroll drag is required in order to get it to work. It's a bit of a piece of shit. Oh shit, wait, no, this is supposed to be maximized anyway. Mate. Alright, what's going on here? Yeah, let me just quickly Google how to do this properly. Golang map literal. Ah, okay, I have to put like map string. What is this then? It's like reset this. Oh no, it's reset fine. I just have to be careful. Oh, and it says what? Okay, it says the key and the value. Okay, no, the value is oh my god, I have to write down like func. Does that work? Undefined RF. Oh shit, this doesn't work. Because I don't have access to RF outside of the code, it gets like passed around like hell. Well, I can just define a struct, can't I? This obviously doesn't work either. Yeah, I literally just wanted a quick dictionary that I could use. Well, what I can do is just be a bit less efficient and put it up here in the phaseChange code. Missing return at the end of what function? phaseChange. Okay. Anyway, those are the phases. We just run init phase. As picked out by the key, which is the to phase. That function is executed, and then we'd return true. Else, return false. Okay. If block ends with a return statement, so drop this else and outdent its block. Fine, it's just telling me what to do style-wise. But yeah, okay, I got a bit distracted there, but you take my point. This is what this does, right? It's just shift my butt slightly. Yeah. Oh yeah, this doesn't immediately return true unless I don't run this in a go routine, but that would mean that I can't run. Okay, so the point of my phaseChange function, I wanted to say, there might be some teething difficulties in practice, but the point of this is that it's I can write I want the phase to change, but if the phase has already changed, it just returns false, right? Um, Otherwise, it doesn't. Well, it doesn't even return because it runs the initialization function. So once that is finally returned, it will return true. But that's not important because it was going to return anyway after that point. True is not important. It's really the false that I care about, because if it comes back with false, it should handle that somehow. So yeah, returns true if the phase changed successfully, but that's only after running the function code. Else it returns false. This will always be running a phase change synchronously though. But I can always run go phase change. But I can't because, no, I shouldn't do that. So let me do sync ball, which is is it or is it not synchronous? Is defer run after a return? Well, no, as in when the return statement is hit. Sorry, let me just move the mic up and everything. How does go's defer run work again? It's like if I defer, then that piece of code executes when return is called, but I think it's executed before the actual return. That would fit the best with existing programming practices, so that's probably true for that reason. Yeah. So this is just my helper function. It's not necessarily easy to get helper functions right, but I think this basically does what I want it to do. So I can specify true in order to run things synchronously, and false to run them asynchronously. And then it just returns true either way. Okay, so just remember it doesn't return true immediately if we've done the synchronous run, because then this has to return first. But that's quite a minor detail. Because I don't actually care too much about it returning true. Okay, all good. That's all I have to say about that. So let's just use phaseChange to explicitly do phase changes, yeah. This is saying if the phase is candidate, so it's an extra check. But the most important point of this is that it just fails to process. It does not run a function if the phases are actually the same. Okay, so we're not going to be running multiple initialization functions. So that's all good. Just got to be careful with the lock here. There's an extra lock because we are checking if it's candidates again, which, yeah, makes the code a bit less efficient. I guess what we should definitely do is just refuse a phase change. Within phase change, we could refuse a change from leader to candidate. Sorry, from follower to leader. So we can actually use this to have permissible phase changes if we want, but for the time being, even though the code's less efficient because of locking and unlocking twice, I'm happy enough to do that regardless, pretty much. So just phase change, you have to make sure that that is run outside the lock, but otherwise, yeah, this is all good. Fine, I'll put this on the other side of the lock. So here we leader should be synchronous, should be true. Here we just we call election, so it's not a phase change. So I'm very much now distinguishing when the phase actually changes rather than just when it does another loop within the existing phase. You know, explicit phase changes. So yeah, let's just implement that everywhere now. The phase change, being a bit brave, implementing that everywhere. But yeah, because I just want to guarantee that phases are changed, are not, changed twice. So again, the election code just explicitly checks if something is candidate at the beginning. Heartbeat checks if the thing is leader at the beginning. And yeah, in its follower, this is the stuff that is, you got to be careful about. Well, all that the follower is doing logically in our new paradigm is calling an election. And because I'm going to trigger this asynchronously, I can just call the election straight off. If the phase is not follower, just return. Because this is again loop code, tail recursive. And then timeouts, we have it loops here, or it runs in its candidate and becomes a candidate. And then immediately returns. So this is asynchronously now becoming a candidate. Ooh boy, messy, isn't it? The code is a bit. So here we have again RF phase is follower and go is in its follower. Instead of that, we're just going to run RF dot phase change follower. Literally just so that it fails in the case that it's already in that phase, and also just talking about whether we want it synchronous or not. We have to explicitly decide that. So again, just have to make sure that we do not run this stuff within locks. So I guess we're going to have to stop using defers. just to make sure that we do not deadlock from locking the code. So yeah, I'm just implementing that pretty much. So just being careful to get the locks outside of the phaseChange, because phaseChange itself is a process that uses locks. You know, RPC term sync, it might make the code slower, but it just seems like a reasonable way to guarantee that we do not, we run a phaseChange, but we don't. I guess another way I could implement this that would get rid of the need to keep locking and unlocking is to assume that we have a lock while this is run. But the problem with that is that init phase is run within here always. You know, there's a synchronous mode that allows init phase to be triggered. So maybe, yeah, maybe for, oh, but then you're saying, oh, maybe we should split lock and unlock on the, split lock and unlock, so that unlock is always happens in a phaseChange, but lock never happens. Could get a bit complicated to do that, to be honest. Yeah, it's an interesting point. Because otherwise, yeah, the code is just going to deadlock here while waiting for the lock to come through. For now, I'm going to keep the locks and unlocks separate, so that anytime there's a transition between functions, the thing should be unlocked. RF, the lock on the main object should be unlocked. So I'm going to make sure to do that. Always unlock before running a phaseChange. So here we unlock and then phaseChange. Oh, that's called election. Okay. Yeah, let me just go through the RPC handlers then. This is a phaseChange to this is a phaseChange to follower. So always preceded by the debug statement. Okay. Here as well. phaseChange to follower asynchronously. No, there are still definitely situations in which I can imagine a follower loop, multiple follower loops starting. Unfortunately, it's just kind of hard to get that straight in your head without the experience, I guess. But it's okay, you know, however far I get within the next half an hour, I've decided I'm just going to leave it there and move on and come back to it refreshed. And, you know, even if I'm not done with the debugging here, we'll see if we can sort it out eventually when I come back to it. Yep, RF phase change to follower is going to be run here. Well, no, this is asynchronous, so I can't just defer and unlock because no, I can't because this immediately picks up the lock and asynchronous. I can't run go phase change. Can you not? I can run go phase change. I can run the phase change thing synchronously as well if I wanted to. So much redundant code, so much inexperience. Yeah, I can run the entire phase change routine as a go concurrently. But you know the problem with that is it doesn't return true or false anymore. But I mean, we don't need it to do that. We just need it to make sure that it only does a change, and you know it can silently just do nothing if the phases are already the same. If I allow it to be called as a go routine, currently I'm sticking to the idea that it's not ever a go routine. Oh god, this is gonna mess up. Yeah, I'm just kind of becoming aware of the fact that I'm making quite a lot of changes without any testing at the same time. It's probably time to just jump on and start testing. So I'm gonna have to see this change through to the end, but then hope that it sort of has worked out fine. Just unlock in the right place. And yeah, request votes. I did the phase change here. Print statement, phase change. Last one is here. Unlock. Print statement, phase change to follower. Unlock. Yep, just checking that nowhere do I have that screwed up. Lock and unlock. Okay, let me just make sure I've checked all of them. So send append entries, you know, lock and unlock and phase change outside of that. Asynchronous follower false. This as well, just phase change guaranteed at the end of append entries. Request vote, phase change to follower. Again, outside of the unlock statements, and the handler here, yep, also does unlocks and phase change and then exits out. Okay, what about all of these? You know, the init functions, I imagine I might even just get rid of them eventually, because they seem to all be fairly trivial. You know, phase change will decide whether or not to call asynchronously or not, as in concurrently or not. Then yeah, heartbeats, you know, takes the lock and unlocks and returns if it's not a leader, and just keeps going. Doesn't actually have to commit a phase change ever. Await election. Well, await election just deals with channels, no lock here in the first place. It just does election reset. This is the tail recursion, but of course if the timeout happens, it just does a phase change to candidate. And then, yeah, election call. Which steps up the term. Votes, vote counts, votes go in, arguments, requested args. Yep, and here it just makes sure that it's candidate still before doing the vote count. Yeah, what I'm going to do is just a quick selection here. To be able to debug, I'm going to make sure I just know what happened where. So this happened, else. It's not that the candidate lost the vote, it's that the candidates lost candidacy. So I don't have, the one thing I don't like about this is I don't have the terms, the voting terms, in any of the print statements. So I'm going to struggle to debug that directly. I might put them in later, but for the time being I don't have them there, unfortunately. Okay, the main code as well. We should, not forget about this. This literally is just an introspective thing, so no changes are done by that. Persistence not implemented, start not implemented, but make I have to be careful about. It runs a go rf.init follower. Phase change. I can just do that outside of my phase change function if I want to, but I may as well, in order to fully test the phase change function, run phase change here as well. And the print is going to be rf.me became follower because initialization. Everything starts off as a follower. And I'm happy for it to become a follower. Well, make needs to return, so this has to be called asynchronously. Make needs to return immediately. Okay. Jesus Christ. Yeah, let's just hope for the best, man. This is just messy, and God knows what's going to happen. Go. Yeah, okay, let me just set up the environment, cdds.init.sh. Go test, here we go, go test run. Let me just, so an idea I had yesterday, I'm going to number the tests. So I'm going to call them, 2A1 and 2A2. Just so that I can immediately call tests using 2A1 and 2A2. It should make things a lot simpler. So I can just go like that and run the relevant test. Oh boy, let's hope that this works. Give it a sec to get started. No, it seems to be working. Ah, wow, okay, that's worked. Well, this is what was working before, but as you can see, the actual append entries seems to, as in the phase changes, seem to be ticking as well. But okay, I have a slight problem here. You see where it says received heartbeat? There's something slightly wrong with this. I'm going to honestly try my best to get the code running absolutely perfectly. Received... Oh yeah, received heartbeat is implemented in append entries. Handler, here it is. Oh, okay, so it... Phase change... Oh, right, okay, I understand. So, I'm, writing here, follower, not follower. Okay, sorry, I just need to take a little break because I'm sitting on my butt in an uncomfortable way again. So I'm just going to move to a slightly position where I kind of sit on like I'm sitting on my heel pretty much. That's what I'm doing. Camera. Sorry, microphone moved. Okay. No, this is all good. This is all good. So yeah, I have, my debug statements are not saying whether or not the phase change actually succeeded. But I guess I'm happy with that, even though phase change itself is not tested. If I were unit testing, you'd bet that I would be testing that. But because this is I don't really know how to test things in Go. I'm only using their own tests, MIT's tests, to debug. I'm going to have to, unfortunately, make assumptions about that kind of thing working. So yeah, there are reaffirmations, and phase change then doesn't actually run. But now that we have more debug statements, I'm going to see if I can run through this and whether or not it works, right? So both of them are initialized as followers, and then the test command jumps out. So 2 times out. The whole timeout code is... Where did I even write that down? These are some redundant statements, to be honest. Well, I wouldn't say that they're totally redundant. Candidate reset, and here there is an actual phase change happening, so I'm going to go with follower reset, and this is actually like candidate timeout. It turns into a candidate just because of timeout. There's no other reason it would turn. So again, I'm bracketing these terms in the case where I'm not explicitly calling a change of state, and not bracketing them where I am. That's just like my convention for the time being. Go test run 2A1. Again, let's have a look at the code. The debug outputs. Test 2A initial election. 2 candidate did a timeout. 2 requested votes. Okay. Request vote. Yep. This dropped out. 1 then became a follower because its term sync failed. Well, 1 was already a follower. But if there is a term sync fail, 1 is going to time out if you're not careful. It would be nice if I could reset. Whenever something becomes a follower, as in it's told it should be a follower, it would be nice if I could reset the election timeout. Just have to be careful, because if something's not a follower, it's not going to be detecting that, and so you can block the channel. And God, concurrency is hard, man. These both replied with true. 2 then received votes, okay, and it decided it was a leader immediately, elected with 3 votes. Yep. It sent out 2 append entries, which came back with true, and then 0 said it was follower because it received a heartbeat. Then 1 became a follower because it received a heartbeat. This is happening slightly out of order because of the append entries receiver sends to election reset before it, before it says that something became a follower. So it detects this first, but then it'll say later 1 was a follower because it received heartbeat. Yeah, so I mean, I don't know if it's worth really looking into that. 2 is definitely sending out heartbeats, they're coming back fine. and resets are happening, received heartbeats. Yeah, the resets, I mean, first the actual exchange happens, the heartbeats exchange, and then it says it does a reset, and then it says that it received the heartbeat. It doesn't really matter. I'm not sure. Maybe it will matter in the future, but for the time being, I'm happy to just allow that and let it go and try to just look into the next test. Wow, total crash. What was the problem? Look at the length, just the length of this dump here. Stack dump. You know, it threw a panic, and it was unable to tell me why it threw a panic, which is strange. Does that mean there's just an undebuggable error? Might it be a lock error? Might it be a if you unlock twice it breaks? Let me just try to test that quickly. The way I'm going to test that is in the original Raft initializer. I'm going to take the lock and lock twice, unlock twice, just as a way of testing, right? Let's see what happens when we do that. So what I'm doing now is testing what happens if you lock while the lock is already held, and what happens if you unlock if there is no lock held. So let's do that. This is going to deadlock hard. Fatal error, all go routines are asleep, deadlock. That's what I thought. What about the double unlock? Double unlock. Unlock of unlocked mutex is giving me a fatal error. Do you know, I think unlock of unlocked mutex should just be ignored. Is it just me who thinks that? Golang ignore unlock of unlocked mutex. Mutex is the lock, of course. Yeah. I'm probably not going to be able to get that to happen, so let's just I think that's what the problem is. Let me see if I can debug it by getting the output into a separate file so I can read it nicely. Go test run 2A2. You know, and we'll be able to see the exact place where it crashed as well, in principle. Oh shit, I'm supposed to, sorry. Save it to an output file that I can read. Alright, this is what happens. You know, everything's going smoothly. One timed out, it requested votes. 2 became a follower because it term sync failed with 1. You know, at this point. Then it sent out a response. Yeah, in general, the way I've implemented RPC term sync, you know, the append entries comment synchronously follows the term sync fail error. Well, not necessarily, because it might launch a Go routine, but no, if it launches a Go routine, to turn something into a follower, that's always going to be concurrent the way I've been doing it. A routine that turns something into a follower, that's not urgent, so I've been running those concurrently, and so it should just immediately continue executing the code and list the failed and the RPC term failure just before the send that, the RPC message that triggered it. So here, for example, 2 is replying to 1, and in doing so 2 became a follower. And I'm pretty sure if it appeared after here, then it would be, if it said 1 follower because of term sync fail from the same RPC, I think it would list it down here. I'm not certain, but 2 became a follower. Well, 2 was already a follower, but it didn't have its candidacy timeout reset, unfortunately. I might see if I can implement that one day. So it also requested votes and led to a term sync failure. Then all this happened. 1 became a candidate. And then 1 actually received votes and got elected leader. And then 2 became a follower. But then, 1 is a leader. And here it says 1 vote interrupted. So that's a bug. Not necessarily, actually. It became a leader. That's all well and good, but and then it said vote interrupted. That means it was running another vote at the same time. So yeah, I probably should not allow things to run votes at the same time, but I mean, call election should be just tail recursive and initialized once. So yeah, it's gonna be hard to figure this stuff out. Vote interrupted, 0 to 2, 0 to 1. So yeah, 2, received a heartbeat, and therefore its vote was also interrupted. And here is your unlock of unlocked mutex. It's a shame it can't tell me where that happened. Look, I mean, 1 became a leader. 2 votes. 2 got pushed to be a follower, 2 still a follower, and then 1 received a heartbeat from 0. Yep. I think we have to not do that. As in, we have to not set to candidate if just because it's received a heartbeat. As in, set to follower just because something receives a heartbeat. Instead, we should rely on term sync and the fact that that should only elect 1 leader at a time. Let's do that. So I'm dropping out the append entries changing to follower by always changing to follower. I'm just immediately dropping that out and replacing it, relying exclusively on term sync to say that something needs to become a follower, okay? So yeah, mutex just has to be unlocked here. No, it doesn't need to be unlocked, sorry, because phaseChange follower false is working. asynchronously triggering, so we can just unlock at the end, okay. Yep, no more turning into a follower, not gonna happen. This locks. Yeah, but you're running phaseChange, which means you have to unlock at the point where phaseChange is run. That is going to be unfortunate. Yeah, or else it will just lock up. Oh god, this is such a hack. I'm just dropping the mutex here because running. Oh great, my webcam is fucking ringing. Is it still working as a webcam? Yeah, it is. Yeah, that's totally fine. But I mean, what the hell? Having a ringing webcam is just stupid. Levels of stupid. Yep, I mean, you know, phaseChange, the way I've designed it, the code has to be unlocked when this happens. So I think this should fix it now. It might even fix the mutex error. Let's see how it goes, guys. Oh shit, it passed. I wonder why it passed. It doesn't seem like it should be passing. Well, nick of time for that to pass, to be honest. Look at that, it's 2 minutes before I said I'd finish. Bloody hell. Seriously, man. Seriously. 0 follower, 1 follower. Okay, let's see what happens. So 0 became it timed out, became a candidate, requested votes. 1 and 2 term sync failed and so turned into followers. They did reply though. Yep. You know, every RPC should be seen through to the end, and it just leaves. It just finishes, and whatever happened, happened. So 0 received votes and got elected leader with 3 votes, and then it's doing append entries and resetting. You know, these are now no longer getting assigned to follower. They're just having their election timeouts reset. Receiving append entries, unless there is a term sync error, is not going to lead to something becoming a follower anymore, which is the correct way of doing it, I think. 2 timed out, requested votes. Then 1 timed out and requested votes, but 2 managed to receive a couple of votes. It's just waiting for the RPC timeout from 0 to finish counting its own votes. But then because 1 requested a vote after that, because 1 requested the vote after that, 2 had to become a follower. Which is unfortunate. But then 1 is in the middle of voting. 2 timed out, requested vote, and therefore 1 became a follower. That's chaotic, isn't it? 1 timed out and requested votes. So 2 became a follower. The thing is, eventually 0 comes back to life. So even though neither of these has successfully turned into a leader. Eventually 1 managed to turn into a leader. Eventually. So, you know, 2's vote gets interrupted. Twice? I feel like I'm not exiting the follower code correctly. So I need to, in my debugging, I need to say things along the lines of, I can't believe this test even passed. Like, it's total chaos. I think 0 remained the leader the entire time, even when the network was healed. This failed to elect a new leader. So the test just didn't actually, it didn't even pass, really. This is such a fake pass if ever I've seen one. I think the test has just not been designed well, because the original leader, it only passed because the original leader came back to life, and it totally failed to elect a new leader. And it's set, 2 is sending out append entries and then it gets deleted again. So, okay, 2 did manage to get elected leader. Okay, I guess that did happen. But, yeah, you need to there are 2 things that are going wrong here that I need to debug. Number 1, exiting the, so we have loop routines here. While it's a leader, it is doing this. So here, I'm going to go with type, so I'm going to get the code to, I'm going to get the program at this point to tell me that this thing has exited from being a leader. So I'm going to have like exit commands. So here it's exiting from the leader code, right? Await selection is the same idea. It's exiting from follower code. And here oh shit, there's a mutex error here. Didn't even notice that. This must be unlocked, absolutely. Exit follower and exit leader. And exit candidate as well. So all of these, whenever they are called, we do a quick test at the beginning of the function to see if the thing is what it says it is. And if it's not, it just quits before running the function. But it's a fundamental question of how often can you wait? How many times can you try to check that something is in the correct phase? Because you can't just because of a phase transition shut down a routine. There's no way of detecting that that's happening. You have to explicitly check for it. And so I'm checking explicitly at the beginning of each routine, but then I also have some other mechanisms in place that can call interrupts. Like here, while it's waiting for votes to come in, it can get interrupted. And in this case, it's definitely a follower. So this will make it slightly easier to debug. Have to wait a solid like 15 seconds these days for the test to actually run, which is strange, isn't it? So where are my exit statements at? I put the exit statements in, right? Don't know why they're not coming up. Yeah, definitely put the exit statements in, but this does not seem to have printed a single exit statement. Oh, okay, no, there are a few exit statements. Not many, though. One became a candidate. So here it's not, at the point where one became a candidate, it did not exit out of being a follower. So let's see if we can fix that. So these select statements, it runs a single select statement, right? Phase changes to candidates asynchronously, and then, oh no, sorry, there are, the thing exits from being a follower just by getting to the end of the function. Right, okay. Oh, so that then doesn't actually admit that it happened. Okay, but I mean here there's a phase change to candidate, right? And then what happens after that is this function exits. It does not call any other. It doesn't call itself again. So here I can also put in the exit follower statements. Okay. I can do that for the others as well, pretty much. Here it exits from being a candidate because it returns, and if I travel all the way to the end, you know, it asynchronously calls itself at the end here, so there's no exit in this situation, but in the situation it became a leader, it does exit because, you know, this if statement is run, this is run synchronously, so you've got to be careful here. But the point is that when that returns, you know, the synchronous run of this, when that returns, it jumps out of the if statement and comes to the end of the function, so that's also definitely returning. And finally, exit follower. You know, if await election is run, it stays as a follower, else it's run a phase change, so it exited follower. Oh no, that's the one I've already done. I want leader exit as well. But no, there's no leader exit because this always calls itself in the same thread, and so it will just hit exit leader eventually and return. Okay. Come on. Let's hype it up, get it all done. This is just, yeah, a couple of notes I made earlier about init being, you know, run when there is a phase change and failure. Nothing happens if there is no phase change. So yeah, here we go. 0 became a follower. That runs, you know, the follower routine, 1 follower, 2 follower, 0 candidate timed out, then 0 exited from being a follower. Extra space there, I need to watch out for that. Whatever, it's just aesthetics, how many spaces you have. It is just but a matter of aesthetics. 0 requested votes, right, 1 became a follower because of term sync fail, and 2 did as well. They were already followers, so, you know, that's fine. 0 received votes and became leaders, exited candidate, and then all this is working completely normally until the point where it stops responding. So 2 candidate, and then it exited follower. It literally stopped being a follower and requested votes, and then 1 became a follower, but of course 1 becoming a follower while it's already a follower does not reset the candidate, unfortunately, the candidacy. It's kind of difficult to do that because if something is a candidate and you send to its election interrupt channel, its election timeout channel, then it doesn't actually get reset because it only runs that code while it's a follower. So I think I need to, just like conceptual error there, the way I've implemented this, right? So again, I'm looking at the follower code, which maybe I should just rename follower. Follower awaits an election. Only the follower is in a position, you know, it just does all this code, which is quite quick. You know, the code is not going to lock up there, really, unless it could deadlock in the situation where this read of phase doesn't work, but that's dodgy. You know, I can see potential for deadlock all over this code, unfortunately. So just didn't implement it very well. But yeah, the point is reading from election reset can only happen in certain situations. Sending to election reset. Do we think we can... Yeah, actually, the thing about election reset, actually, now that I think about it, if you've seen how append entries handles it, right? It triggers an election reset. It sends a message to it in an anonymous concurrent routine. So it's trying to send the reset, and if that, because it's been put in an anonymous go function, that's not going to block anything. It's just going to keep trying to send the resets, and then when the thing eventually becomes a follower, which probably will happen, even if it doesn't matter, although it's a bit leaky memory-wise. When it becomes a follower, it will just drain all of the reset commands and literally get reset. So basically, I can do this in the request vote handler. I can trigger an election reset, right? Yeah, I can do that, and I can do that outside the mutex. Basically, this should make the code actually. So what I'm saying now is whatever, if anything received an RPC, if it received append entries, there's probably a leader. I'm going to hold off the election timeout. If it received an RPC from a candidate, a request vote one, something is doing an election. I should probably hold off on doing my own election. Okay? That's a very simple idea that kind of passed me by initially, I guess. Whenever there is an RPC, that has to have been sent by a leader or a candidate, and that means that anything receiving it should probably hold off on timing out and becoming a candidate itself. Okay, that's my thinking. Ah, fuck, we hit another mutex error. This dump is just so useless. To follower, well, at least it's it's actually showing up all of the errors that I've been having. Look at this, to follower, term sync fail. So the append entry sender had a term sync fail, which is a mutex error. Sorry, as in there was a term sync fail, and then we ran phaseChange. Oh shit. Double unlock of a mutex. Very simple little error that I had here. Just because the way I've structured my code, I cannot use defer, which is a nice way of unlocking a mutex because it just makes sure it unlocks when this function returns. But because I'm calling functions synchronously in certain situations, not in this situation because it's just it's an asynchronous phaseChange. Yeah, in this case it is actually safe to just defer. So I'm just gonna fucking do it, But in that one case where I'm calling true, so synchronous phaseChange. Oh shit, no, I can't do that. Sorry, because wow, I'm confusing myself. No, mutex has to be unlocked. Even if this is an asynchronous call, the actual phaseChange itself needs to pick up the mutex immediately. So yeah, the unlocks have to keep happening. They have to. Yeah, sorry. It's just my inexperience. Maybe I should sit down and, well, it's probably what I'll do when I resume the project after my hiatus. I'll sit down and have some, have a good long think about some of my mutex practices, and I'll just reason through different ways of doing locks, as in a lock is a mutex, mutual exclusion lock. And think about different ways of doing that and different ways of implementing the phaseChange protocol, which as it is always requires a lock, but there are so many different ways that could be implemented that it would be really good to just have a sit down and consider some of them. So currently I'm working with one way of doing it, which as you can see is making debugging not easy. But at the same time, if I can get one method working, then I'm in a position to compare it to other methods, and so I'm going to hope that I can do that. Alright, well, listen, for the time being, well, I fixed the fucking mutex error. It literally always just has to look like this. It has to, the unlock has to be in an else block. Which I've also noticed it's not here, so I'm just going to preemptively fix the same bug in different places. In the senders. So the senders have the else block as well. In this case, I'm just having a permanent lock going, so here I unlock and then relock. Because yeah, more or less the whole of this is more or less the entire append entries handler has to have the lock. So it's just here where I trigger a phaseChange. I'm just like, yeah, trigger that. Drop and reacquire the lock, unfortunately necessary there. Okay, but that didn't fire, or else it would have been an error, so that wasn't what caused the problem here. Let's again run through and see if it works. One candidate timeout, request votes, and then 0 and 2 become followers, and hopefully they now time out correctly. So 1 receives votes and becomes leader, exits candidate, and then it is working, everything's working, then 1 fails, okay? The thing that is leader, that thing fails. 2 times out, exits follower, request votes. 1 is not contactable. So 0 becomes a follower because of term sync fail, sends its vote over, but then 0 becomes a candidate as well because 2 is still waiting for the damn vote to arrive. I don't know how long the RPC timeout is, but yeah, this is definitely a problem. Do you know what is definitely a problem? You need to, I think, at the point where vote counts, don't vote count at the end, but vote count just in time, and then move to the next bit of code once the vote count succeeds. That will make the code a lot more efficient, because then it doesn't have to wait for votes to come back from dead computers. It will time out and it will work, but the problem is in the intervening time, what could happen is it could take so long that something else times out and calls a vote, right? So that's an interesting conceptual bug there that I just thought of. So I'm going to fix that in a sec. I just want to see if that's kind of explaining what's happened here. So, yeah, 0 timed out and became a candidate while 2 is still waiting for its votes to come through. And then 2 loses its entire election as a result because of term sync fail. It has a candidate. 2 as a candidate, that piece of code. Oh wait, no, sorry. 2 requested votes, but then what happens to 2's vote? What can happen? Right, 2 requests votes, and then it has to wait for votes. It's possible election reset will have fired, because every voting RPC fires a message into, literally every RPC fires into election reset. So I'm supposed nowhere does it say 2 vote interrupted. As in 0, requested votes, and then, but there is no 2 vote interrupted message, unfortunately. I don't know why. But as you can see here, oh yeah, 2's actually become a leader. It's interrupted the vote of 0, so 2 is working fine, but 1 is sending messages as well, and a couple of different things are wrong with this. I've noticed a mistake. That mistake is that firing election resets from the RPCs should not be happening if something is out of date on term. That, like, explicitly, if something is out of date on term, it should not be able to fire any kind of reset. So you got to be careful. This should not be happening, right? Election reset true, which is I'm putting currently I have it at the top of both of the request handlers, right? Both of those should not be happening in the situation where the RPC is between this thing, so the self, and the thing that it's talking to is out of date. Right? So if my term is out of date, then I do this. Right? But if the other person's term is out of date, if the other person's term is out of date, I'm going to put in extra lines of code here. It's going to make things a bit messier, but yeah, do not fire a reset. So yeah, if args, if my term is, so this is saying if it's not the case that the other server's term is less than mine, then fire an election reset. Because if it is the case that the other one is less, then the other one should get updated and should reset itself, but I'm not resetting myself. I am only resetting myself if the one whose term I'm talking to is beyond mine. At least mine. So that is where that line should go. Yeah, it's messy and difficult to reason with, definitely. So this is another term sync type line of code. This is also all about synchronizing term, right? In a slightly different way. So, you know, I resynchronize myself if this happens. If it's less than or equal to, I become a follower. If it's strictly less than, I become a follower. But if it's less than or it's equal, that's a good enough excuse for me to fire off an election reset. So I'm gonna put that also in the term sync line of code. With the reply.success is in a different place in the two sections, but that's not massively a problem. The reply.success is something that I'm not actually bothering to test at the moment at all. Okay, so that's settled the election interrupts, and the other thing that I was going to settle that I mentioned earlier is aggregating votes on the go and quitting when we have enough votes, rather than waiting for all the votes to come through, which is just an idea, right, of mine. Pretty much just if vote, then vote count. I'm going to, just do a line of code here. If vote count is greater than or equal to this thing, which is like the majority. Should I just define that as a variable somewhere? Yeah, here. Majority votes is going to equal this. Length of peers halved, right? So if vote count is greater than or equal to the majority, that's what we care about. What's happened here? Yeah, I haven't actually put that in. If that happens, just continue. No, not even. We're not even in the select statement, so we can just break out of the select statement fully if that happens. Okay, so if we have achieved enough votes, then this will break out. That's it. Those are the two changes that will fix this, hopefully, to get it working within the kind of specification that I would like it to work in. Wow, 2 claims to be a leader. That's a disaster. What's happened? God, I don't want to spend too much longer, but I feel like I am getting closer. Closer, closer, closer. Problem is, yeah, we have 2 things that are leaders, because one of them got disconnected. 2 is the initially elected one, right? Then 2 gets disconnected, and okay, 0 requests votes. Receives a vote from 1, and then it triggers 0 received votes because it has enough votes from itself and from 1. That's working correctly. Oh, yuck. Petrol outside. Big whiff. Just life in London, the kerosene. Right, so 0 starts appending entries. 2 is obviously just not. What does it send? It manages to send, 0 exits being candidate, but it manages to send request vote. Yes, because 2 is just timing out, so the request votes are dropping really late. That's not a problem. Ignore that. 1, it's all working. 1 is a follower. 2 is failing still, so 0 is sending to 1 successfully. 0 got elected as the new leader. Right, and then eventually 2 comes back to life. Turns into a follower because term sync fail. And yeah, eventually it exits the leader as well. So 2 stops sending append entries, so that's correct. This is working correctly. 0 breaks down. 2 times out. Exits follower, requests votes. Two receives votes, but no vote actually happened in this term, which is a bit strange. So I think the problem that's happening here is 2 is receiving votes in the wrong term. So 2 turned into a leader, but it's sending out append entries again. 1 timed out, turned itself into a leader, and all the append entries messages crashed. So literally all of these things have gotten disconnected from each other. I can't tell what the problem is here. I think append entries might be hanging. Well, as in it's sending out sender messages but no receipt messages. So the append entries function, I think, might be locking up. And failing to return. Let me just, I'm going to run that test again to see if it happens again. So I think that's the problem here. Just make sure I've rerun the test correctly. Yeah, it's getting to the position where I think append entries is continually hanging. This is not returning correctly, so what's the problem with it? The terms are all synchronized. But here, sending us an election reset, that's all well and good. It's not getting to the point where it can comment this. But like, which bit of code could that possibly be breaking? Maybe the sender is crashing. What, the sends entries? It sends this, it does the call. Yeah, but then that should be running the receiver code, so like. Yeah, look at this. All of these, you know, it's continually sending out append entries, heartbeats. Oh, no, I think I know what the problem is. I know what the problem is. You're getting stuck on heartbeat because this code here hangs. It doesn't hang, but this needs to be concurrent. The next heartbeat absolutely has to be concurrent, and the reason for that is that is there a reason for that? The reason that I didn't make it concurrent in the first place, you know, my initial thought just now, as in my thought as to why this was happening, is that heartbeat was just taking up all of the CPU, so it never returned. You know, it keeps sending out append entries, and but there's no other routine happening. So append entries received is not triggering, but append entries sent out definitely is triggering, and that is triggering in concurrent routines. So that's not the problem. What I thought it was, that this is hanging. You know, so send append entries is triggering. This line of code gets run. The RPC code comes back. But append entries received is just not coming through for some reason. Right, so I have now append entries, send, receive, reply, all of these things just listed out. Reply is getting hit, but the receiver is not functioning correctly. That seems like a really weird bug, and it doesn't seem like it's my fault. Reason being, you know, I've sent out all these messages, I'm getting timeout replies. But this is just saying that nothing is communicating with anything else. So I think, yeah, what the test does is it crashes the entire network. But then how can it be a test failure that, you know, two things are claiming to be leader when it's expecting no leader? How can that be a failure when the things are not communicating with each other? They can think what they like, surely. You know, but, oh shit, you've done something wrong here. You've managed to elect a leader with only one vote. That's definitely wrong. Okay, so slight bug here. Because we're in a situation with three of them, so a majority is 2, not 1. So I have my majority is incorrectly defined. You see? Majority is 1.5. Oh, but no, actually, because it's an integer, this is probably getting floor rounded. Yeah, so let's just use the ceiling function. Transforms to float the results of the division, but that's an integer division. What does... In this example, page size is 10 and length is 43. So if you do 43 divided by 10, it's an integer division, you get 4. So you need to convert everything to float. Okay, so what I'm saying is in order to divide the number by 2, this is doing a floor division, but I need it to do a ceiling division, so I'm gonna hack that, I guess, by just going like, okay, convert both these numbers into floats. This is a float. This is now reinterpreted as a float. That is majority, which is now a half integer. And so I want to do int math.ceil to convert it into its ceiling. Okay. Is math actually imported here? Yes, it is. So that should work. Okay. God, no, but what's happening with the RPCs getting dropped is a really weird error. Yes, there is definitely a problem that you're... Oh no, but it's not even really a weird error, is it? It could just be completely intended if the network is fully disconnected. Lots of sends are happening, timeouts are happening, but the receipts are not happening. That would be consistent, actually, now that I think about it. So yeah, the full disconnection happens like somewhere in this test. So 2 has failed. What happened to the others though? They seem to have completely stopped working for some reason. I mean, what? Okay, again, let's just start at the beginning. You know, 2 is a timeout, votes, it gets its votes, 1 becomes a follower from the handshake, the RPC handshake. Request vote, 1 sends a vote to 2. Yep, so 2 has received enough votes. See, it's received 2 votes at this stage. You know, exits from being a candidate, sends append entries to everyone. You know, 0 becomes a follower, 1 is already a follower. This is all working fine. Append entries received and replied. And resets and happening. Okay, and this is where 2 breaks. 0 becomes, you know, request votes. Request votes. Why does it say 1 candidate timeouts? You know, there was no phase in which 1 became a candidate. Ah, sorry. This is saying 1 becomes a candidate because of the timeout. Okay? Fine. It seems to have, yeah, failed to respond to this thing on time. That's fine. Oh, this is like a split vote, basically 2 things calling a vote at the same time. So yeah, 0's vote gets interrupted and 1's vote gets interrupted. Okay, fine. Nothing happens. Try again. Try again? What? Why is there no retry? 0 and 1 both got their votes interrupted. Okay? And so they should just be throwing votes again. Oh no, this returns out of the... This is within the election code. Their votes both get interrupted. Right? And what that means is the interruption means that they need to both become follower again. Ah, okay. So the reason I didn't, yeah, this used to have like become follower used to be written down in the code here. Okay. The reason it's not written in the code anymore is because I at one point decided that append entries should be turning things into a follower anyway. And so I removed that from this piece of code. But now both append entries and request vote can turn things into followers. And trigger election resets. Well, no, sorry, request vote doesn't even turn anything into a follower. It's not guaranteed to trigger that, but it will be firing into election reset regardless, and whatever is reading from election reset, even if it's in the candidate phase, has to be in the position to back out and say, okay, I'm now a follower again. So yeah, just literally just trigger a phase change to follower. Yep. So vote can be interrupted by someone else voting, calling a vote, and vote can also be interrupted by append entries. So any RPC is liable to interrupt the vote, okay? So this is now a trigger to convert into a follower. Vote interrupt. Right? And so are we in mutex here? No, we are not. We're not in mutex at all. Yeah, we're not in a lock. So we can just straight off trigger phase change into follower here. And return. Yep, asynchronous trigger into follower. So this will also definitely straight out return. So I'm gonna, yep, just dump that down as an exit candidate as well. Because it's just before the return. Yeah, these exits are like, let me just find them because I want to get rid of the spaces that seem to be before some of them. Neat. Literally just the the spaces. All the spaces have to be in position. Ah! A space appeared. Fuck that. Alright. So yeah, trigger a change, and this is like a safe trigger of a phase change. Like I'm saying, it should become a follower. It should become a whatever. But if it already is, then drop the phase change and just let it continue doing whatever it was doing. So it should be safe. Success? Ah, fuck yeah. Alright, this is the first success I've actually had from this test that I believe is actually a success rather than just a fake success. I've had a few of those. Okay, let's reason through the code and hope that, you know, it passed. Whoops. Oh my god, it's such a long test. Look at this. Yeah, it's extensive. So what I'm going to do actually is rerun the test after I delete a few print statements that are not necessary. I was trying to debug append entries, but then I realized that it was a full network partition, as in everything was disconnected from everything else, and it wasn't a problem with append entries. So, you know, the RPC was working fine. It just was timing out because everything was disconnected. Earlier, that was a problem I had, but I don't have it anymore. So, okay, I dumped. For fuck's sake. Oh, command's not found. Thanks Linux for being helpful. After like 2 seconds of thinking, oh, command not found. Alright, Guan. So I've run the test again. It passed again. With a lot less, yeah, many fewer lines of comment, but that's because I deleted them. Let's reason through it, okay? This is fucking it. I'm done. I'm finished. RIP 2A, RIP 2A. Okay, everything is initialized. Here we go. 0 becomes a candidate, it exits from being a follower. It requests votes. 2 and 1 both fail to sync term because 0 is ahead on term. I really need to put in like RPC term communication. Do you know what? I'm gonna do it. I'm gonna do that. I'm gonna, every time an RPCs are exchanged, I'm gonna put in term information. Okay. What's the simplest way of doing that? Because they are actually synchronized so that they are equal to each other. I can't just put in a comment at the beginning because that's not how my code works, unfortunately. Unless I want to explicitly put in another comment. Should I just go like... the self thinks that this is the current term. Okay, this is not all of the information I wanted to convey, but it's a start, and I'm happy to just put it in. So yeah, the self, again, Jordan Rakai, himself. What did I do? Syntax error, so I fucking comma somewhere. What? No. Sorry, what? Where the hell is the error? In a different line of code. Does anyone see a syntax error? Okay, we're on 39 at the beginning. It says unexpected reply, expecting comma. Sorry, what? What are you talking about? This is just such a nuisance error. If I cut that out, what happens? Nothing. If I paste it back in, what happens? Ah, okay, spotted. Yeah, well, no, I didn't see the comma, and then the debugging tool was just not useful at all. Okay, so now I have the current term at the end of an RPC handshake. Information about that is going to be just chucked in to the thing. Okay, so all I've done hopefully is change some print statements. I'm running another test. Hopefully it will also have passed yet again. Yep, it continues to pass. Awesome. And you know, this number is the term. Okay, so we have a bit of introspection on what the term is. See, it's a number that's increased to 3. Check it. Okay, let's follow the code and see what it says. 0 follower, 1 follower, 2 follower. Why are they followers? Because initialization makes them followers. At the beginning, everything is a follower. Okay, 0 turned into a candidate because of a timeout, and the follower code exited. So, you know, I'm trying to, this isn't guaranteed, but my exit statements are hopefully at the point in each of the routines for each of these programs where the routine exits and does not call itself again. That's the hope. God, the code is just, God knows, such a difficult system to implement. Really a human achievement to implement in distributed systems properly, I have to say, without any bugs. This is hardcore, seriously. So let me just check my camera again. Yeah, I'm happy to just let it go. Okay, check it. So it's candidates, it's, you know, set itself to candidates and exited the follower loop. Requested votes. 2 and 1 both term sync failed on both of their respective handshakes. Oh, I've only put this in the receiver, so this is what the receiver thinks the term is. I'm also going to put it in the sender, so we're going to introspect the sender as well with this. Okay, so I'm introspecting the sender. Where is the damn sentence that the sender does? Oh, it's at the very beginning. Oh, so I've put responses to receive at the end, and I've put responses to send, as in I've put the log for send at the beginning. That's not good because you know, the 2-part phase. Nonetheless, I'm not going to change it because lazy. It's kind of a bit messy to do that, I think. Instead, yep, I am just sending over rf current term in the send. introspecting the current term here. Print statements that do not follow the conventions, the correct conventions for locks. Still not sure what to think about that, but I do not have time to worry about that for the time being. rf.current term, so I'm just noting down the current term. Okay, so now I'm doing the fourth test. The fourth test, if this passes again, did I change anything? I didn't actually change anything, did I? It just failed the test here because term 1 has 2 leaders. Yeah, this is another problem in my code that has occurred to me quite late on and I haven't fixed yet. It's that whenever we do votes and leader elections, we have to guarantee that every vote is assigned to the correct term. We have to have very strong assertions about how to do that. I don't think I did change anything, man. I swear I literally just tried to introspect some yeah, maybe I just shouldn't be doing that. Okay, I'm gonna revert that last change, the introspection of term, because it might be causing it might be causing a race condition or something. So maybe maybe I shouldn't be so quick to violate in my print statements that stuff. You know, it could be causing problems. God, it is fucking annoying how the control button just does not pick up my little finger. Yeah, that could just be a race condition that I triggered myself by introspecting the variable. Wow. So yeah, maybe I have to lock everything. Everything has to be locked. Well, obviously other than things that never change, those don't have to be locked, obviously. So, you know, the list of peers, who am I among the peers, that's always fixed. But yeah, that seems to have triggered a failure, which is surprising. I've now undone that change. Well, the thing is, this other print statement is done within the lock, so that's not going to cause, you know, the term introspection is not going to cause a problem there because it's done within the lock. Is this one done within the lock? It should be. Huh. I've screwed up the code here. If lock, you know, lock, and then we do the term sync, which has to unlock for the phase change to happen. It's perfectly legit to trigger a phase change. Oh, no, it's not, because this is synchronous code, okay. Right, oh, I think I understand. Yeah, this is, because we're doing stuff with current term. Lots of stuff with current term. This needs to be locked, okay? That's just a mistake on my part. Lock, unlock, then we trigger the phase change, then we have to lock again after that. And not unlock the final thing until the very end of the code. So we lock again, all of this stuff goes off, we're introspecting so much, you know, current term, as in we're accessing the current term variable, so we absolutely must make sure that we unlock at the end. Lock it, so it's fully locked here. There's just a temporary unlock in this line. Okay. Surprised that that didn't cause some sort of race condition. I'll do the race condition testing as well at some point, maybe not on this stream. It's already going into 3 hours, even though I tried not to have it last so long. Okay, well this shit still works. Oh my god, Zero got elected by 1 vote again. That's just... How is that happening? Didn't I explicitly say, like, quickly, if I need to deal with this ASAP, seriously. A tour of Go. Okay, what I'm going to do is log some floating point numbers, because I want to see if my majority definition actually works. So take a look at this. Right. Oh yeah, could have been majority anyway. So again, I'm changing 3 in and I'm printing B because I want to see if this gives me 2 as it should do. Right, so import math. Yeah, it is giving me 2. So, you know, vote count should be coming out to 2. Ah, sorry. So we have to have another vote count greater than or equal to majority test at the end, okay. Bug detected, even though it passed the test. Do I believe it will pass the test again? Maybe that's how I managed to elect 2 leaders in 1 round. Okay. Let's just, run through this. Everything is a follower, 0 becomes a candidate, requests votes, both of these term sync fail, and reply with the up-to-date term, which is 1. And then they both get reset as a result of that, because they're out of date, so they get a reset trigger on the resets the election timeout basically. Yep, 0 received votes and then it was elected with 2 votes, as is correct. Well, I mean, it was also elected with 2 votes, but it has basically at least 2 votes, It actually received 3 votes. It's 2 plus votes. That's fine. 0 exits candidate, then we are, appending entries, all of that's working fine. 0 crashes, 1 times out, requests votes. 2 term sync fails, but then it replies with a true, and 1 receives votes and becomes a leader because it got 2 votes. It exits from candidate, then it is keeping in touch with 2, which is constantly resetting. 0 is failing to send messages still. 1 is perfectly legitimately, being a leader. 2 is being a follower. 0 here comes back to life. It gets hit by term sync fail. My god. 0 gets hit by term sync fail. God, so close to the end. I just don't want to be distracted. 0 gets hit by a term sync fail from this communication, and then its term gets updated to 2, but it is now a follower. Just a quick thing here. I've triggered the phase change to false.
And so I should, yeah, write that as a explicit phase change, sorry, rather than, okay. So term sync fail now explicitly causes a phase change in all situations, but reset doesn't. Reset just means it stays a follower. So yep, 0 is now in check, 2 follower gets reset a couple of different times. Never mind, that's fine. 0 exits from being a leader, fully, I hope. 1 is now the only leader in this situation. As you can see, it's communicating properly, the term is not increasing, 0 and 2 are following its lead, then 1 crashes, 0 times out, requests votes. But now nothing is working. This is the bit where nothing is working. 2 times out, exits from follower, 0 exits from follower, request votes. Loads of request vote RPCs, and 1 still thinks it's leader. The other 2 think they are candidates. So 1 is doing that. So there are 0 leaders in this situation. Then 2 receives votes, namely they are all false. And so it loses the votes. Then it requests the votes. 0 follower. Aha, it comes back into contact. One of the old votes, God knows which one, comes actually contacts. So yeah, when 0. Oh right, no, sorry, this is 0 receiving vote from 2 request. 0 is now out of date. Request vote. So 0 actually does vote for 2 in term 4. 2 receives votes, becomes leader, exits from candidate, and then sends something to 1, which is still not working. 0 becomes a follower because it's voting period while it was waiting for votes. That gets interrupted. 0 exits from being a candidate, and then 2 has 0 under control. 1 is still out of, still not connected, but then 2, heartbeats 1, and then 1 penned entries should probably say send or receive. Let me just chuck that in. This is the receiver. Yep, okay. So this is the receiver. So then 1 replies with true, updates its term. They are both now on 4 after that handshake. 2 sends to 0 and receives from 0, 4 still, and so 1 and 0 are reset. 1 exits from being leader. So now 2 is keeping both 1 and 0 in check, and it passes. That works completely correctly, finally. It's done. It's over. I did it. I did it. I did it. I cannot get excited even. Because it was just, another 3 hours just to get to this phase. Definitely a break is needed. Definitely I need to reassess how long everything is taking me. Okay, now that I'm going on a break, I'm gonna make a to-do list, okay? So there is a bunch of stuff here that I'm still not happy is working correctly and could cause problems in the future, so I'm gonna put it on the to-do list. Fix this shit later. So, number 1 is term logging. So the print statements should be for every RPC comparing both terms before the RPC is sent out. So before the handshake happens, it should compare which one is which, and then which one, and then they come to an agreement on their terms, which currently I'm only logging in the receive phase of the RPC. So the send phase, no information, and the receive phase, that's fine. So I'm going to be doing that. I'm also going to fucking, what else? Guarantees for votes to be synced with terms, because we had a lot of errors along those lines. They turned out to just be me implementing the majority incorrectly, but could still cause problems, and Yeah, do you know, that's just about it. I mean, I have codes that passes the tests fairly reliably, I think, now. So just, yeah, do better in the future. Implementing lots of other stuff. Does it pass 2A1 still? I mean, it must do. 2A1 is a simpler version of 2A2. You can, if you want, just, yeah, run both the 2A tests. Yeah, that's it. So I'm gonna pick it up later and try to, you know, I mean, it's chaotic. I don't feel like I'm really in control of my codes that much. You know, I don't have such a clear understanding of what's going on with everything. Why is this so long? Yeah, the testing is really wrecked. You know, the code just continues going and does not get shut down. I think this is the code from the initial test. It literally just persists and then it gives me a pass at the very end. But if I control F passed, I will find 2 passed statements. Why did it test 500,000 lines of... probably just because I'm logging so much stuff. I mean, it claims it passed, I'm going to just accept that it passed. Yeah, no, that's it, that's what I mean, that's what I'm saying. To do a pre-hiatus summary. Okay, to do a pre-hiatus summary before I finally finish everything and just fully stop. Okay, let me just, yeah, I'll go ahead and delete this out file and then just, yeah, do a commit on the log. This is after session 6, past 2A, okay, that's where we are now. Okay, listen. Listen, listen, listen. You need to know about the balance. The bank account balance. The Barclays balance. Yeah, basically. Yep, I'm going on hiatus now. The position I'm in at the moment, I have finally passed 2A, finished it, passed the test, it's done. But there is a lot of chaos, a lot of potential for problems, a kind of lack of conventions, a lot of stuff that just needs to be fixed. And of course, we need to then go through and implement the next bits of code as well. You know, I think I'm going to have to go back and edit my scrap, which talks about how the algorithm works. There are definitely some inaccuracies there. I guess I may as well just chuck it into todo, even though I committed the damn todo. What was an example off the top of my head? All the... Yep, so for the sketch, for the outline, fix outline, what can trigger an election reset? Timeout reset. You know, answers on a postcard. Every RPC where I am up to date. No, it's not even that. It's every RPC where the other is up to date. that can trigger an election timeout reset on my side. That, for example, is something that I didn't pick up on in my initial outline. Nothing else off the top of my head, but so I'll just leave it there. But yeah, going through the scrap, tightening it up, then trying to implement the next phases, probably going through the code and simplifying it a bit. It's a little bit complicated at the moment. And also, as I said, post-hiatus, finishing the Raft project, doing parts B and C. I'm also going to be trying to keep a bit more chill, not working for as long sessions, probably try to get 2.5 hours per day I'm doing it, and set a really loose deadline for when I'm going to finish it, because it's just difficult, it's just very difficult, and having an over-optimistic deadline for streaming is what added to my pressure and burnout, so quite happily I will just take a break and come back and then be in that much better position. Okay, sounds good. Yeah, that's all I have to say. Again, when will I resume? Well, information on the Twitch channel, and also information on my Twitter account. Probably I'll post when I get back on it. I have very much enjoyed Raft, but I'm starting to enjoy everything less, just from pushing myself too hard, I think, and yeah, underestimating how hard it would be. So a break is in order, and then I'll get back to it. And it's a lot of hard work, a lot of things to fix, but I'm getting better and better as I do it. The better I get, the better I feel about the stream as well. When I'm really struggling, I'm just like, oh, this must be a torture to watch. But yeah, that's just how it is. That's part of the learning experience. Usually it's kept private, but I have it in all my sort of 17 and a bit hours of glory. In which I finished MapReduce, completely finished it. Raft, I've only done the first part out of 3, but it is finished, passing the tests and everything. I reasoned through all the debug logs, and I don't see any problems at all. So just be better, push on, and I'll be alright. It'll all be alright in the end. I will have finished the Raft project, a really tight distributed system, and then move on to the others. I will definitely do the others as well. Just a question of when, and also a question of if I will stream or not. Like I said, the downside of streaming is you get a bit less motivated to keep pushing through with debugging and that kind of stuff when it's just kind of dry and difficult to keep explaining some things that are kind of muscle memory automated debugging and that kind of stuff, but also just to continually have to explain everything that could potentially be a problem, and it's a bit exhausting. But I mean, it's part of the experiment, and I'll see how I feel about it once I do the next bit, which will be on stream, namely Raft parts 2 and 3. So that's all I have to say about that. No real technical problems like I had in MapReduce. It's been going fine, just, well, other than Raft logging way too many things. So yeah, no problems. I sort of know what I'm doing, what I can improve, how everything can get better, and so I will just kick off and do that next sesh, which will be in July, probably almost certainly in July, because it's just going to be a struggle to keep this month in check. 14th to 17th, that's 4 days of me being out and about. Gig in Peckham, Cheska, all those gifts. Whoever turns up to that, I don't know, might bring a few people along. 15th, I am out visiting a company, a business analytics company, well, a sort of strategy, like a kind of strategic analytics. Just talking about software in the workplace, I don't know. See what comes of that. 16th Pokemon Go Community Day, and 17th a friend visiting from the US. We're doing some shit. 18th to 23rd, probably 19th, 20th to 23rd, I'm off to Cambridge. Come back from that. 24th is SGDQ, clashing with the World Cup. I'm just in my house all day for a week. And then when July hits, everything is wide open again. So really, 1st of July onwards, the project could come back, distributed systems. It definitely will come back within July. I can pretty much guarantee that. Question of when, and so I'll just post about that on Twitter. And on my Twitch account, it will all just be laid out and clear. Cool. I did it, I guess. I got through all that stuff. Feel okay, not too happy still, just because of the kind of chaos caused by this, how hard I found it, and expectation reality. But yeah, just lots of staring is going to be necessary. Staring at the code, which is definitely easier to do off stream. Staring is just one of those methods that I use to fix stuff that is completely wrecked and I don't know where to start. Just stare. Highly effective when doing maths. Imagine streaming yourself trying to solve a maths problem. You can definitely stream a lot of useful stuff, but you cannot keep up with your subconscious, really. That's the point of staring. It's a highly effective problem-solving technique. Bringing it back to Imre Leader, I mentioned maybe 25 hours ago. Stare at it a bit, right? And he literally did that during lectures. He would spend 10 seconds staring at the blackboard, just to teach people how to stare. Because staring is an important skill, right? You don't know that staring is an important skill when it comes to problem solving. So yeah, that's it. Yep, thanks for watching. Anyone who's been watching, everyone who's just tuned in every now and again, I do appreciate it. It's made things a lot more entertaining. Though I appreciate this stream is not only is it not marketable, but it's also just difficult. It's so long, and there are definitely good bits, but it's just hard to find them. Because, welcome to the real world of Komsky coursework. But yeah, I appreciate it, and I've appreciated all the chat that I've done with people in the meantime. So yeah, that's it really, that's all I have to say. We'll be back in July. Thanks very much. Peace out to all the mans inside.